Hello everyone. So in this lecture, I'm going to explain how to convert a one flip-flop into another flip-flop. That is realization of flip-flops. So there will be no procedures will be there while converting one flip-flop into another flip-flop. So the step number one is first write down the characteristics of the required flip-flop. Okay. So which flip-flop we are need to convert, that flip-flop characteristic equation first we need to write. Then present state and next state table of the characteristics of the required flip-flop we need to write. This is the second step. That is in the previous lecture only we have been discussed the four different types of flip-flops to tables. That is what here we are going to write. Then we derive the excitation input values for the given flip-flop. Yes, the first two steps for the required flip-flop, and the third step is we are going to write the excitation input for the given flip-flop. Okay. And the fourth one is we are going to obtain the KMF for the excitation inputs. Then the last step is we are going to draw the combinational circuits for the given input and feedback to get the input for the given flip-flop. And this is the basic block diagram for the representation of the conversion from one flip-flop to another flip-flop. So see here, this is what our given flip-flop, and here the inputs are for the required flip-flops, and the feedback actions are coming from this Q as well as Q bar. If it is necessary, then we can take the values from this Q and Q bar. Okay. So here the block is a combinational circuit, and here it is in a flip-flop. Right. You see some examples for this conversion of one flip-flop into another flip-flop. So the first one, realize a D flip-flop using SR flip-flop. So here D flip-flop is a required flip-flop and SR flip-flop is a given flip-flop. Okay, so step number one, the characteristics of the required flip-flop D flip-flop. That is, we know that D flip-flop when D is equal to 0, output is equal to 0, and D is equal to 1, output is equal to 1. That is what the characteristics of D flip-flop. This step number 2, write the present state and next state table of the required flip-flop D flip-flop. See, the present state, create a column, 3 column. First one is the present state Qn, and second one is the input D flip-flop, and third one is the next state Qn plus 1. Okay, fine. So input is input is D, so it is a single variable, so two combinations is possible. One is 0, 1. So for this 0, 1, I'm going to consider my present states as 0, 0. Okay, and another set is present states are 0, 1. Sorry, 1, 1. Okay, so present state we are having single variable, so we need to represent two conditions. One is 0, another one is 1. So here inputs are having two set of conditions 0, 1, 0, 1. So for the first 0, 1, I'm going to consider my present state as 0, and the second set I'm going to consider my present state as 1. Now, as per the D flip-flop truth table, we need to fill this next table. That is, see, input is D. Don't bother about this present state. Only for it is suitable for D flip-flop. Okay, in D flip-flop, whatever may be the present state value, just look at this input. That input will go to the output. See, 0, 0, 1, 1, 0, 0, 1, 1. So here, there is no use of this present state. Okay, fine. So now we have written the present state and next state table for the required flip-flop. And step number 3 is from this present state next state table, we are going to identify the excitation inputs for the given flip-flop. That is, the SR flip-flop is given. So again, we need to create the table. See, present this just continue from the previous table, present state, input, next state, and here put the heading as excitation input. So SR flip-flop we are going to use, so R and S. Okay, right. So in the last lecture only I have explained how to design excitation table for all the four types of flip-flops. Okay, so while go for an excitation table, Qn and Qn plus 1 is going to act as the input, and S and R is going to act as an output. That is, this is excitation inputs. Okay, so 0, 0, 0, 1, 1, 0, 1, 1. So for SR excitation inputs, that is 0, 0, it is 0, don't care, and 0, 1, it is 1, 0, 1, 0, it is 0, 1, and this is don't care 0. This is what the excitation table of SR flip-flop. So see here, Qn is 0, Qn plus 1 is 0. So 0 0 as per this excitation table it is 0 don't care. So here R is written first, so here I will change don't care 0. Then Qn is 0 and Qn plus 1 is 1. So 0 1 it is 1 0. See 1 0 is written. And 1 0 here 0 1 is written. And 1 1 don't care 0 is written. Okay, so don't bother about these inputs, only consider this present state Qn and the next state Qn plus 1 for finding the excitation inputs. Okay, fine. So now step number 4, we are going to find the expression for the excitation inputs. That is, we are going to find the expression for R as well as the expression for S using K-MEM simplification. So while considering this, while finding the expression, we are supposed to consider only present state as well as the inputs. Present state and input alone. Okay, so do not consider this next state. So here two variable is there. So two variable means we are in need of a two variable K-map. One is present state Qn, another one is input D. So have a look at this. Q1 is taken here and D is taken here. So this is for S and this is for R. S is having two places. The values 1 and don't care. So here two places are written filled and one pair is formed. So for this pair the expression is D. And similarly for R also one don't care, one is the two places. So here two values are filled and here the answer is D bar. Okay, so S value is D and R value is D bar. So now as per the block diagram of the realization, so the first one is here combinational circuits decoder, that is next state decoder will come, and the second one is required that is given flip flop. So here S and R is given, so here S and R will come. So here S input is what? S input is D, so D will comes here, and R input is R value is D bar, so here one NOT gate will comes. So have a look at the next picture, you can easily understand. So see, this is the flip flop, given flip flop, and this part is the combinational circuit. Okay, S value is D, so D is connected directly here, and R value is D bar, so here one NOT gate is used, so this is D bar and Q bar. So hence we have realized D flip flop using SR flip flop. Okay, we'll move to the next conversion. Realization of JK flip flop using SR flip flop. So here JK is the required one and SR is the given one. Okay, so see, JK is the required one and SR is the given one. So first we'll start from the characteristics of the required flip-flop JK. So we know that JK four conditions is 0 0 0 1 1 0 1 1. So this is no change and this is reset condition and this is set condition and this is the toggle condition. Okay, fine. So let's create the two table, that is a present state, next state table. So present state first column and the inputs are J and K and next state is Q and plus 1. So J and K are inputs, so four possible combinations. See 0 0 0 1 1 0 1 1. So this is the first set and this is the second set. Why I have used two set means here Q and present state is 0. So one time it is going to act as 0, another time it is going to act as 1. Right. So now, as per the JK flip-flop truth table, we need to fill this next state Qn plus 1. So 0, 0, there is no change from the present state. So the same 0 will come. 0, 1, the J value will goes here, 0. And 1, 0, again J value will comes here. And 1, 1, it will toggle the present state. So present state is 0. So now it is changed into 1. Similarly 0 0 there is no change, so the same 1 will comes here. 0 1 J value will comes here and 1 0 J value will comes here. 1 1 it will toggle the present state, so present state is 1, so now it is 0. Okay, so hence present state and next state table was constructed. Then we are going to find the expression for the next state Qn plus 1 using K-map simplification. So just consider only present state, sorry. The next step is excitation inputs. Okay, we need to continue with the same table, and we are going to include some extra inputs, that is excitation inputs S and R, because the given flip flop is SR. So have a look at this. SR is written. So while filling this excitation input, just consider only present state and next state. Okay, so 0 0 in SR, it is 0 don't care. Again it is 0 0, so again it is 0, don't care. Then this is 0 1 0 1, so next two conditions are same. And this is 1 1, don't care 0, 1 0, this was 0 1, 1 1, don't care 0, 1 1 0 1. So 100. Okay, so the excitation table is very important while designing, that is while converting one flip flop into another flip flop. So now we are going to find the expression for R and S using k-map simplification. While go for a k-map simplification, just consider present state as well as the inputs. So present state is single variable qn and the input is j and k. So totally three variables is there. So we are in need of a three variable k map for finding the expressions of R and S. So have a look at this. Here R is filled 2, 3, 4 places, and here the S is also filled in 4 places. So here 4 values are filled. This is for yes, and here it is for or. So here there is no use of don't care, so we are going to form the group here. It is pair, so the expression is, it is qn bar and j, so one multiplication term, so we are in need of one AND gate. Okay, fine. So here again qn and k will come, so this is also one and it is needed, so from here the next last step is, now we got a s and or expressions. Now we are going to draw the final logical diagram. So s and or, what is s value? S value is q n bar j, so q n bar j, and r value is, it is q n k, so q and k. So q and bar is here. See q bar. So the line is taken from here, one input, and j is actual input. And for this qn, so it is taken from here. Okay. Now you guys are understand. Just you may just remember that the JK flip flop diagram. So J and K, and one clock will come. So that clock is commonly connected here, and feedback actions will come. Okay. So this is what JK flip flop. Okay. Fine. Next, realization of T flip-flop using SR flip-flop. So here the required flip-flop is T and the given flip-flop is SR. So have a look at this block diagram representation. So first step is characteristics of T, and the second present state next state table is for T flip-flop only we are going to write. So present state input next state. So T is a single input, so 0 1. So 0 1 because present states are 0 0 and 1 1. So T is 0, there is no change, the same Qn will comes here. T is 1, it is going to toggle the present state, so 0 is changed into 1. Again T is equal to 0, there is no change, so 1 will comes here. And T is equal to 1, it is going to toggle, so 1 is toggled into 0. Okay, then excitation table, again we are going to add a SR flip-flop here. So the excitation inputs are an S. So we know that excitation table of SR flip-flop. So as per the excitation table, we written this one. Next up is find the expression for R and S using K-map. So here we'll go for a K-map, consider present state as well as input alone. Okay, so two variable K-map is needed. So let's R and S. So here S expression is Q and bar T, and R expression is, this is R. So R expression is, it is Q in T. Right. So see here. Um, so this point is from Q bar, and this point is from Q, and here is the single input T. Okay. So this is what the realization of T flip flop using SR. Fine. Next. Realization of D flip-flop using JK. So here the required flip-flop is D and the given flip-flop is JK. So see, given flip-flop JK and the required flip-flop D. So we are going to find the first, we are going to discuss the characteristics of D, and in step number 2 we are going to construct the present state next state table of the required flip-flop D. See, present state next state, this 0 1 0 1 will comes here. Then excitation is JK. So excitation inputs are JK. So as per the excitation table of JK, just consider Qn and Qn plus 1. So 0 0 and 0 don't care. 0 1 1 don't care, 1 0 don't care, 1 1 1 it is don't care 0. Okay, so keep in mind for excitation table consider qn plus 1, and for k map present state and e inputs. These two things you're supposed to remember always. Okay, so let's find the expression for j. So two variable came up as needed. So j expression is d, and for k, two variable came up as needed. K expression is d bar. Okay, then draw the logical diagram. So see, j is d and k is d bar. Okay, fine. The next one. JK flip-flop using D flip-flop. So here the required flip-flop is JK and the given flip-flop is D. See, given flip-flop is D and the required flip-flop is JK. So now first we are going to discuss the characteristics of JK, and in the step number 2 we are going to write the present state next state table of this JK flip-flop. Okay, so see here three conditions are given and the next five conditions are here. So we know that JK flip-flop truth table, see 1 1 it is going to toggle the present state, so present state is 0 here, so 1 is came here, and 0 0 no change, so this one is coming here, 0 1 this 0 will goes to the output, 1 0 this one will goes, and 1 1 again it is going to toggle. Okay, fine. Right. So now the excitation input. So here the using flip-flop is D. So only single. So for this, don't bother about the present state. Okay. Look at this next state, because we are going to write the excitation. So excitation we need to consider present state and next state. Okay. But here the excitation input is D. So don't bother about this present state. Just copy this next state value and paste it here, because we know that Q is equal to D. That is, the same value will comes this place also. Okay, so now find the expression for this D using K map. So how many variable K map is needed? Present state and input. So totally three variable K map is needed, and we have marked all the values from the previous table, and the expression is it is Qn K bar plus Qn bar J is coming for D. Okay, this is the logical representation for D. The same this diagram only we are going to draw here. So this is the given flip-flop and this is the required one. Okay, fine. So I hope you guys are understand how to convert one flip-flop into another flip-flop. So first of all, we need to understand what is the required flip-flop and what is the desired flip-flop. Okay, so the required flip-flop characteristics as well as the presence in the next state is very very important. Then the desired flip-flop excitation is very very important. Then K-map, then logical diagram. So I hope you guys understand. See you in the next lecture.